If you look at all the spending to do HPC and AI related work, the overall spend rate was around $52 billion in 2024, and we're expecting by 2028 that to reach around $85 billion.
The line was drawn at number 8, so the top 8 machines are as powerful as the bottom 492 systems.
A greater comfort level and a willingness to embrace this notion of a continuum computing, not either on-prem or cloud.
3.5 companies, in essence, can really skew the amount of money that's being committed towards HPC in its most broadest definition, simply because they have the money and the agenda to go out and spend.
From Orion X in association with Inside HPC, this is the @HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
I'm Doug Black at Inside HPC, along with Shaheen Khan of Orion X. Guests today are from HPC industry analyst firm Hyperion Research. We have Earl Joseph, the CEO. He has oversight for Hyperion's overall research and consulting efforts, along with the firm's HPC User Forum, which conducts conferences in the U.S. and around the world throughout the year. We have Mark Nelsikoff. He is Research Director, Lead Analyst for Storage and Interconnects and Cloud. And Bob Sorensen, Senior VP of Research. Among other areas, Bob focuses on exascale, supercomputing, along with quantum and other future technologies. So today we're going to talk about future trends in HPC AI, how the melding of the two has impacted Hyperion's research strategy, and to look ahead to the trends we can expect in 2025 and the rest of the decade. So Earl, let's start with you. From a big picture perspective, share your views on the relative health and growth of the industry, and particularly now that Hyperion has grouped AI under the HPC umbrella or within it. We're looking at some very healthy CAGR numbers for the rest of the decade. Isn't that right?
Thanks, Doug, and we appreciate the invitation to join you and Shaheen today. Over the last 3 or 4 years, we've been tracking the AI portion of the HPC market in much more depth. And there have been a lot of new sellers in the market. NVIDIA, Supermicro, and a lot of AI specialty houses selling equipment which are really non-traditional vendors, and we have included those into our market tracking numbers. The explosion in AI, which started just a little bit more than 2 years ago, has resulted in the market size, as the way we track it, to be 36.7% larger, more than a third larger because of all this growth and increase in use of AI. But in addition to that, this whole recognition that high-performance computing, computing at scale, and AI capabilities, it's lifting both the AI portion of the market plus the traditional HPC portion, because government agencies, companies are all recognizing that the use of big data, big HPC, and scaling can do a lot of good things. Now, that's also changed the growth trajectory that you were mentioning. If we look at the overall market right now, we're expecting to see around 15% annual growth over the next 5 years. That used to be 7 to 8%. So the market is more than a third larger and growing at roughly double the growth rate that we were seeing before. The other parts of the market that are growing tremendously is cloud computing. And the way we track that is what HPC end users, researchers, engineers, analysts, and others spend in the cloud itself. And that we saw in 2024 grow by 20%. So just a phenomenal growth for year, almost large enough to call it a tipping point year. And then for last year, 2024, for the on-prem AI servers, we saw those grow by 40%. So just some phenomenal growth rates in the market. And to put it in the big picture perspective, if you look at all the spending to do HPC and AI related work, so it'd be the on-prem servers, software storage, maintenance, plus cloud spending, the overall spend rate was around $52 billion in 2024. And we're expecting by 2028 that to reach around $85 billion. So just some tremendous growth taking place.
Earl and Mark and Bob, it's such a treat to have all of you on this call. And thank you for making that happen. And thank you, Earl, for that sort of setup for the market. What do you think is causing the growth in cloud? I have several questions, of course, but just to start, is the cloud adoption, you feel it's related to just the inability of on-prem data centers to handle these emerging CPUs and GPUs from power and cooling standpoint, or is it really something else?
Perhaps we can all three share some ideas. I'll start with a couple of them. Cloud computing has become much more useful for HPC, meaning the cloud providers have created better software, better environments, and hardware approaches, and their prices have gotten a bit more competitive. But some of the gigantic drivers is the relation of new technology. NVIDIA and AMD have announced that they're going to have new processors every 12 months. So if you want access to the latest technology, cloud is one really good avenue. In addition, the supply chain issue. If you wanted to get an NVIDIA Blackwell, let's say a couple hundred of them right now, the waiting list is more than 12 months. So the difference between buying on-prem, which means you buy something now and you have to keep it 4 or 5 years, you're going to be multiple years behind in technology, really is driving a lot of people to use the clouds for more parts of the workload. And I think Mark and Bob can add to that.
Yeah, hi, this is Mark. I'm happy to be here, and thanks for including us in these conversations. To add what Earl said, I think there's just an also just a comfort level from the users and research that are utilizing. They've gone through the various stages possibly of resistance and acceptance, and now are in evaluation and more understanding of what makes sense to run in the cloud and on premises. So just a greater comfort level and a willingness to embrace this notion of a continuum computing, not either on-prem or cloud, but how can I best utilize and embrace the cloud across all my workflows and optimize resources. Something that's been coming about as well is this notion of sometimes referred to as neoclouds, or the really focused attention of AI as a service or GPU as a service in a more just focused resource provisioning that differs from the broader cloud providers like Google, Amazon, or Microsoft Azure that provide a wide range of services across the full spectrum. But these neoclouds are focusing on just providing the AI or GPU as a service kind of activities. And maybe one last item I'll comment on before turning over to Bob was that there is a sustainability element as well, as organizations are still tasked and have goals for energy efficiency and sustainability. There's a migration to the cloud that can be more efficient of resources and remove the carbon footprint and power utilization from on-premises for what they would be on the hook for measuring and reporting, that then gets deferred to how the cloud providers are tackling the issue.
I guess I'll go now. For those who are listening at home, trying to decide which voice is which, I'm Bob Sorensen. I'll be the one who'll be speaking too fast. So hopefully that'll help you out. I'd like to kick the discussion along because I think we need to move away from on-prem versus cloud to on-prem and cloud. I think it's really time for organizations to understand the fact that if you could sum up the opportunities here, if you have capacity, if you have the need for a specific workload that you know you're going to need for the next 3 to 4 years, you have your architectural requirements and your budgetary requirements in sync, then maybe on-prem is the way to go. If you're looking for resource access, some of the things are all talked about, emerging technologies, NVIDIA coming out or trying to come out with at least a new product at a higher cadence. New technologies, what's going on in some AI space. A lot of the cloud service providers are looking at offering their own AI accelerators. The easiest way to explore that opportunity is through the cloud. And so I think that really thinking about how one can solve their computational capabilities by a much more sophisticated mix of on-prem versus cloud is something that I hope we see in the near future as organizations say, we have a diverse set of needs. Some of it's predictable, some of it's reliable, and some of it we'd like to have in-house so we can kick the tires on the machine we own. But at the same time, we want the flexibility and perhaps the low barrier to entry to explore new technology, and the flexibility from a budgetary perspective to basically bring new technology, new workloads to bear, or maybe even doing some workload balancing. So what I'd like to see in the near future is a lessening of this us versus them versus everybody kind of holding hands and singing Kumbaya going forward.
Bob, it sounds like it's a much more complex managerial task to oversee how you put together this hybrid mix on-prem, off-prem. But let me ask a very concrete question. Earl, you mentioned a 12-month waiting period to get your hands on Blackwell chips. If you went to the cloud, is that immediate? Are Blackwells immediately available?
Immediately, as long as you have the pocketbook for it. But yes, you can start your job almost immediately if you go with the cloud. And when I mentioned the 12 months, if you actually wanted to buy quite a few of them and put a larger on-prem server in place, The 12 months is how long it takes to get the chips from NVIDIA right now. So whoever builds the system would probably need another 4 months. So you might be looking at 16 months. And a good example of why that's such a big problem is if your boss just told you to, hey, figure a way to use AI and do this great stuff on Blackwell, you can't go back to your boss and say, give me 16 months to get a machine on board, then I'll start working the answer. Whereas in the cloud, it's give me 16 minutes and I'm going to be up and running.
Yeah,
So
non-starter.
the differential there is massive.
Yeah. Now, at the risk of complicating this, Bob, you mentioned that if your workload is predictable, then maybe you want to be on-prem. But it's also true that if your workload is predictable, you can get better prices on the cloud. Maybe part of what we're looking at is that this stuff is just going to cost one way or another, and it's not for the faint of heart or somebody who has a limitation with budgets. That's also true, isn't it?
I would argue that the idea here is that when you procure an HPC, you're really thinking about a 3, 4, 5, or 6 year budgetary commitment. And that actually number is actually getting longer. I'm not terribly aware of cloud service provider agreements that really extend out to those kinds of.
Right.
So there is some variability going on here in terms of what can I commit to on an on-prem procurement, which for certainly a lot of government organizations and a large subset of commercial organizations are pretty much in sync. So the bottom line here is that some organizations are already geared towards these long-term budgetary commitments. And the cloud, doesn't offer that kind of long-term commitments, certainly for even their largest organizations. And in my mind, Doug talked a little bit about the complexities of this on-prem cloud happy wedding here. And the concern here is how one deals with a budget where a significant percentage of your budget may be in this kind of 3, 4, 5 year procurement cycle. And the other one may be a month by month, annual by annual, maybe 2 or 3 year kind of commitment on the cloud, and how you do resource management and provisioning in those two very different environments. The bottom line here is there are some compelling issues to be attacked and addressed if you're thinking about having a much more sophisticated on-prem environment. And that, of course, doesn't even address the use of software. But here we're talking about budget, and those things are going to have to be worked out. Because it's one thing for long-term commitment, it's another thing for a short-term pay-as-you-go model, and how you reconcile those two things, especially if you're working in a government organization or a large commercial organization that wants predictability and budgetary commitments. Those things are going to have to be ironed out going forward.
Yeah.
Could we, for a moment, let's talk about leadership class supercomputing. Right now, the state of the art, of course, is Exascale. But it's very interesting. There's more talk about maybe the most powerful computing could come out of the cloud providers. Certainly the hyperscalers have money and budget for technology R&D that dwarfs, say, the Department of Energy. What are your thoughts about this mix of, we have 3 Exascale US systems, how many in China we don't know, but how will that work over against or with the HPC capabilities coming out of the big tech companies?
Yeah, first off, Doug, my issue here is the concentration on the highest end of computing nowadays, the so-called exascale systems. And the top 500 list, when it comes out every 6 months or so, one of the things they release is this wonderful metric that talks about drawing an imaginary line. And if you, above the line is 50% of the sum total of the computing power above that line, and below the line is the other 50%. So it's where you draw the line in terms of the average system, if you will. In the old days, the line would be drawn at about 100 machines. So the 100 machines on top were equal to the bottom 400 machines on the bottom. That number has gone down significantly over the last few decades. And the last one, I think the line was drawn at number 8. So the top 8 machines are as powerful as the bottom 492 systems. And so what we're seeing in some sense is an architectural, a power consumption, a cost capability, and a complexity in programming at those exascale class systems that in some way, in my mind, aren't terribly representative of where HPC is going writ large. Certainly not a lot of organizations are capable of spending $6 million plus on a system. They're not capable of funding 50 megawatt systems that may ultimately cost you, in some sense, equal to what the machine cost. You may be paying power and cooling costs that are equal to the acquisition cost of your HPC during its lifetime. So to me, I think that the exascale system mentality has to start to move back into sync with where the rest of the sector is going. Lower power, lower cost, and really what that boils down to from a practical perspective, and we're starting to see this coming out of Department of Energy, is the idea of partitioned, heterogeneous architectures, different subclasses of partitions that address the workloads that matter to the particular organization. And this way, you're not buying one machine every 7 years that costs $500 million plus. You're buying a series of sunsets of smaller partitions that can roll out in time to address your workloads, much more responsive because you're not committing to a single architecture for 5, 6, 7, 8 years. You're committing to an architecture that can evolve over time to address new workloads, address new technology options, and unfortunately address the vagaries of the budgetary process. And that's where I think we're going to go here in terms of Exascale's class systems. And the one thing I'm going to mention, and I'm so glad you brought this up, Doug, we just started putting out these things, we're calling them top of mind surveys. It's 5 quick questions that we're blasting out to the entire HPC world. And I think question number 3 on that was, when do you expect to see a hyperscaler HPC occupy the top 1 slot on the top 500 list? And I think we had, next year, 2 years, 3 years, 4 years, 5 years, and never. But we, as I said, we just launched that, and I really can't wait to see the results of that in terms of what the overall community thinks. The answer to that exact question. If so, when is that going to happen? Because I think that the stars will align, and certainly some organization is going to be willing to commit the cycles to run that top 500 list LinPack benchmark, and at least for the sake of publicity, have a number 1 slot going forward. It may not be there for long, but it may be just long enough to run LinPack. But I think we're going to see it sooner rather than later.
And Bob, I think those are great points, and this is such a great question. My view of the world right now is there's really 3 categories of, if I call them supercomputers, large-scale machines. And one of them is the hyperscalers. Talk about why they're different. The other one is the exascale, or the real giant machines. Bob mentioned the top 500 list shows this too. Maybe there's 8 or 9 of those in the world right now. And then the third group is everyone else that's doing HPC and AI. And they're all going off into 3 different directions right now. But Doug, your question about the CSPs, the hyperscalers, and the social media companies that are building these giant systems, they're not being built to do broad scale R&D or leadership R&D. So I think there's still tremendous room for national labs around the world to really do leadership class R&D. They're much more focused on what I would call a narrower set of problems, whether that's large language models only or 3 or 4 types of AI. But then the bulk of their cycles are sold out to clients, and they're servicing clients at a lower scale. So with an exception of a few of them, they're not fully being used for leadership class workloads.
And Earl, let me just add quickly, we could say 3.5 systems, because to me, we can't ignore the fact that these basically self-built dark systems, the idea of what's going on at, say, Tesla with Colossus and some of these other organizations that are assembling their own systems for their own uses. They're very end-use specific, primarily right now targeted towards things like AI, large language model, or generative AI training. And those organizations have significantly deep pockets. So in some sense, 1 or 2 very large installations by some of these 3.5 companies, in essence, can really skew the amount of money that's being committed towards HPC in its most broadest definition, simply because they have the money and the agenda to go out and spend $3 billion to buy an awful lot of NVIDIA GPUs to do in-house training for in-house end uses. So there, again, the sector is fractionating once again, creating more opportunity, creating more confusion, and just opening the potential applicability of whatever particular flavor of HPC you're interested in.
I have a question, maybe this is for you, Mark, and that's data gravity. We talked about the hybrid model, and is a hybrid model stable, or is it a slippery slope towards one end or the other, or how do you keep that hybrid model to meet the ideals that it was designed to optimize?
I think there's a couple of things there where the data gravity, and I mean, the first and foremost thing is trying to minimize any data movement that has to occur between, as you're leveraging both on premises and in the cloud and the hybrid architectures, that the ability to maybe move the compute closer to where data is rather than moving the data around is going to be critical to doing some of this. Another consideration is the notion of sovereignty and where the data is created and where can the data actually go and need to reside relative to cloud, and who can access the data based on some of the growing attention being given to sovereign efforts, whether it be a sovereign cloud or even other sovereignty related items like the sovereign compute, sovereign LLMs too, as well. How sovereignty is affecting everything. I also want to jump back, if I could, on the investment in AI and how it's impacting the industry. That with all of the investment being driven and chasing the large hyperscalers with the AI, when you consider from the software impact and especially looking at the precision aspects of it. The traditional HPC codes and users have the FP64 based codes, but there's an uncertainty on the commitment of the vendors being able to continue to optimize and extend the FP64 roadmap. So in some sense, kind of a notion or potentially even an acceptance that the workloads and software folks may need to be skating to where the puck is going to be and leveraging and optimizing where their codes, where it makes sense and where it can and should be done to take advantage of all the investment and advancements in the mixed and lower precision areas.
Mark, am I right that big trend in data storage is around this grab bag, if you will, where all sorts of different storage media, different types of storage are all under one roof so that it's all available to these huge AI workloads, no matter in what format it's in or where it is?
I think that's a goal, and not necessarily a nirvana, but where it's going. And the past investments in storage and the storage winners, if you will, really focused on maybe more on the speeds and feeds, the abilities, as I'd call them, the reliability, availability, durability. But those storage systems, not just the features, need to be up-leveled more towards the data management, especially related to AI, this notion of an AI data pipeline, where the different stages within the data pipeline, that as data moves from ingesting to training to or the pre-processing to any checkpointing and then eventually getting down to the inferencing aspects of it, each of those stages in the data pipeline have different I/O profiles, whether it be block sizes or sequential or random and all the other aspects relative to it. So it's a strain and a stress and requirements on the storage system to be able to really address and satisfy all of those. And so the investments that are happening up level or up the storage software stack into the data management and orchestration to be able to provide the data from a common storage system, single storage system, to meet the requirements of all the aspects in the data pipeline is becoming more critical for and the emergence of these data, what I'll call data platform service providers that are emerging and finding success and traction.
Mm-hmm. So that's still a dream and a goal not achieved as of yet.
Not fully, but it's certainly the steps are being taken there. I think it's closer than just a wild dream, but there in some aspects, in some workloads, in some verticals, that this notion of the orchestration and being able to manage across the different data types are being realized.
And Earl, I wanted to ask you. Now, we last saw you at SC in November, and lots has happened since then. I'm curious what your thoughts are on the biggest developments that have happened over the last 3 or 4 months that are impacting the industry overall, the most prominent impacts.
Yeah, just for fun, one of the major changes or line of confusion is what the U.S. government is doing. And the number of changes that are taking place almost on a daily basis is leading to a tremendous amount of uncertainty agency by agency. And along with that, announcements of starting with $100 billion, going to $500 billion to build out 20 new AI data centers across the U.S., and then that being matched by Europe. The French last week announced a major new AI initiative. The Middle East is planning to make major investments, not just on the AI side, but they'd like to even have their own foundries and build their own chips. So the amount of growth is just phenomenal, but the amount of uncertainty too is very strong. I think it's going to take a while before we understand what it means in the U.S. The national security topics and areas clearly continue with investment, but it's very uncertain for us where NIH, the National Science Foundation, and all these places, their funding and operations are being redirected. So learning what that is real difficult at the moment, but that's something we hope will settle down in the near future. The other part that we're finding, at least I do personally, is tremendous amount of AI applications, different success stories, ideas that people have on how they can apply AI. And like I was saying earlier, just large compute with large data, with smart people doing smart software to solve a lot of problems that people previously thought would take 3 to 5 years to solve. And now they're thinking they could do it perhaps even this year. Just use cases everywhere from the traditional mod sim, legal organizations, and automotive design, and a lot of different areas.
And then there's DeepSeek, which was a pretty big piece of news a few weeks ago. All three of you, what are your takes or insights on the DeepSeek phenomenon?
Sure. You'll probably get 3 answers here, which is half the fun. We're just finishing a short write-up on DeepSeek. And a couple things are apparent. They did use a lot of US software. The number of GPUs used were a bit more than they originally announced, and perhaps the cost is higher. But again, this is to me like adding fuel to the excitement fire in the sense that it's started a price war to make AI a lot less costly to the end user. And so I think that part's positive. We're trying to figure out really how real their lower costs are because there's conflicting article and data points out there. And with that, I'll hand it to Bob and Mark.
I think caution should be taken. Yes, what they've done is impressive and what they've been able to achieve and provide the results, but have they, just from a sheer, we do a lot of relative to total cost of ownership, were all the total costs associated with actually getting to what they produced, were all those total costs that others include, or were they all incorporated into what was presented by the DeepSeek folk, what they actually spent to achieve what they've done?
The thing I'd add to the conversation, of course, is that DeepSeek achieved such notoriety by being the number one Apple in the Apple Store. So right up front, that kind of scopes the issue. And so we're an HPC shop and much more interested in what AI means to the science and engineering community, not to the people who want to go out and buy an AI-enabled smartphone from Samsung. And to me, there's some significant issues that need to be resolved if AI is to become a trusted component that contributes to the science and engineering community. It's not just getting the right answer about 85% of the time, which is what we see on some of the large language models and such. There are significant uphill battles that are going to have to be fought before science and engineering can sit down and say we can validate and verify and trust a reproducible, explainable output from some of this generative AI hoopla that's going on out there. And so we're really trying to think if this is a pun on the idea of the tipping point. Is this a tripping point? Has there been too much investment, too much enthusiasm within the enterprise space that's dragging along the science and engineering community that ultimately may not have legs? I come from a certain amount of skepticism within the quantum computing community where people talk about too much investment, not enough realized performance results. And I'm wondering if I know we're seeing huge investments going into the amount of money in terms of every company out there trying to become an AI-centric organization. And if you look at the projections of the amount of revenue that these things are supposed to be generating in the near term, I'm wondering, and I'm not going to say it's a Gen AI winter that's coming, but I think there's going to be a certain amount of reckoning going forward in the next few years as organizations sit back and say, what did all of this spending and expectations deliver us in terms of return on investment from a financial perspective or return on science from a science and engineering perspective? And quite frankly, I think the jury is still out on all this. And the reason that the one data point I can point to that scares me is when that Chinese company came out, NVIDIA stock tanked. Now, it was only for a day or two, but that scares me in terms of the volatility and fragility of what that sector really engenders at this point in time. So to me, the jury is still out. I don't see it as the next turn of the crank in HPC writ large. I see it perhaps as an interesting activity, an interesting opportunity that ultimately will be winnowed down to things where it works best and other things where it's just simply not worth the cost or the labor to bring it into your existing computational workload environment.
Yeah, I think that's excellent.
Bob, I was going to say, I liked your, maybe it was a potential Freudian slip, but is it a tipping point where it's driving an upward trend, or is it a tripping point?
A tripping point,
that we're going to stumble, that we cause some stumbling, and like you said, the challenge and extreme caution moving forward.
Bob, I completely agree, but the DeepSeek phenomenon also pointed to perhaps a situation where maybe we don't need all these resources. Maybe we don't need the latest, greatest chips and interconnects. Maybe there's a lower cost way of getting to the kind of answers that we wanted to. And if so, that opens the whole AI scene to on-chip AVX vector extensions, maybe even CPUs, and maybe we don't need the GPUs. Maybe it can all be on-prem. There's a lot of unknowns, and of course that's what makes it volatile. But how do you square all of that?
I agree, because to me what's happened is because of the intense competition, remember all of this AI progress is being driven by commercial organizations who are vying for mindshare and vying for venture capital money as well. And so they're racing ahead with some very aggressive developments. No one has had time yet to take a deep breath and say, okay, let's start programming for efficiency. For what are the heuristics? How can we distribute this? How can we make it less power consumptive and get better results? Are we overtraining some of these large language models? Do we really need to go to 10 to the 25th operations? What kind of pruning can we do? Where are the optimization stages? And I think that as the sector starts to progress and the programmers and the engineers start looking under the hood, they're going to go, hey, I've got a better idea. I know how to do this a little better. As soon as the technology comes out, the users find a million ways to start to optimize. And I think we're going to start to see that. Look for AI heuristics in the next few years, I think, to become a much more integral part of the overall AI ecosystem. Because right now, it's running full bore, pedal to the metal kind of acceleration. And it's time for someone to say, do we really need to be running at 8,000 RPM? Can we be a little more efficient in how we do some of this stuff? And I think those opportunities are just overflowing in AI. No one's just had the time or actually the inclination as yet to address them. But I think as end users start to bring it in-house, they're going to start to come up with interesting ways to find efficiencies that we haven't even dreamed of yet.
Okay, so I have another question here. When I try to read the DeepSeek papers, some of the optimization methods that they used came across to me as like standard in the HPC world, like overlapping IO with computation. Duh, we did that 10 years ago. And a few other things. Where do you land on HPC versus AI? Do you consider AI just a manifestation of it's an HPC app? Or do you think that this is so fundamentally different, mixed precision, as Mark, you were saying, that is just different? Or even if it came out of HPC, it now is so big and has its own life that it needs to be viewed separately?
I mean, from an algorithm perspective, it's dramatically different. You have these deep neural networks and such that you're not doing a calculation, you're getting a result out that you can't tear the hood open. When you get a result back, you can't go, okay, find me the variable that was at 49%, but if it was at 51%, we can do this. So from an architectural perspective, there's a lot of interesting issues here. But one of the things I like to remind people is that invariably, all code gets translated into assembly and then machine language. So at some level, everything we're doing in the AI world and the HPC world still comes back to ones and zeros that have to do things like compute, store, memory, and interconnect. And so in some sense, it's an interesting confluence of dramatically different algorithms that ultimately are running on the von Neumann architecture that has been around for the last 60, 70 years. And so both worlds, I think, could benefit from a greater understanding of what is brought to the table by each. And that's my point about the HPC world knows how to do those things well, the optimization process, to wrest out the greatest performance out of an architecture that ultimately, when you get to a deep learning algorithm, it's still just a piece of code that's machine language that can be optimized. So I think there's a lot to be learned from both sides. They need to cooperate more, and there needs to be a little more coordination. Certainly architecturally, there's some ways to fine-tune a system to be more amenable to an AI piece of code versus a ModSim code. But again, that's a knowable thing. It only will start to happen, though, as the sector starts to stabilize and starts to slow down a little bit in terms of new models, new architectures, new algorithms, and just new vitality in what's going on.
And Bob, what I'd like to add to that is one view, and Shaheen, this is flipping your example a little bit, is that HPC technologies underlie almost all of AI. And as Bob was mentioning, whether it's the hardware, the GPUs, which were really heavily used and optimized in HPC, the software, the algorithms, the file systems, the scaling aspects, the power and cooling, all these technologies that have made AI successful are really HPC technologies underneath. And so just wanted to add
Really
that.
are, yeah. Yeah, really are. And Mark, to what extent are you seeing special to AI storage requirements, or is it just AI washing?
No, I think it's a little more than AI washing. I think there's storage and some data requirements too. The notion of how big the data sets need to be and how much data should be included in the training. Does the whole universe of data need to be included in some really precise model development and training for a really targeted environment? But in terms of AI washing versus unique requirements relative to AI, there's some notion of of are files needed on some of the aspects needed? Are parallel file systems required in some aspect of it? Or can you move more to object than file-based or even block-based across some of these elements within the data pipeline? There's still an awful lot of evaluation and learning occurring to really decide what's being done. That is a question I ask a lot of the vendors that I talk to. Yes, they're using all of and addressing trying to get on the AI bandwagon, but okay, what are you doing explicitly, specifically that's AI oriented? And there's only a few that are really addressing specific AIs versus really trying to fit a little bit more of what has always been done, but focus it towards AI. So there's probably a little bit, maybe more than some would care to admit, AI washing, but I think as we're evolving and learning is occurring, there are more AI-specific features and elements being integrated into the data platforms. And I'm intentionally up-leveling the vocabulary of storage systems to a data platform to kind of account for that.
Earl, you had mentioned that whole issue of the U.S., now France, Europe. We saw news out of South Korea building out these enormous AI data center infrastructures. Are there any interesting trends going on in the area of power and cooling? Because the compute demand is so far outrunning the power capabilities that are available. Are there any interesting trends there?
Yes, Doug, there's been a lot of different changes, as I was mentioning. The growth rate of these centers are at a higher rate than what we saw previously, and meaning expecting with those countries. And one thing that's always been talked about with AI is once AI more globally is successful and takes place, it's going to launch a tremendous competitive kind of battleground between different organizations. Of course, on the military side, there's been a lot of science fiction stories, but whether you're an academic research institution or a manufacturer, once everyone else or a few people adopt AI, once it's successful, then other folks will adopt it, and there's going to be this tremendous competitive battle. So the requirements of the hardware, we've all seen what that's done for NVIDIA. On the power side, there's a lot of issues, and we're hearing about a lot of nuclear power plants being put online and then ones being built right now. We are aware that China is doing a nuclear power plant build out for their data centers that are at an extreme scale. So all these different countries are trying to address that. And the sustainability and the ability to do your work using less power is crucial to try to power optimize things. We had an interesting presentation at one of our recent user forums where the presenter was showing how they profiled their workload and that it cost them $1 million per megawatt just to install the power into their data center. And even though their system could say do 100 megawatts, it never actually ran at 100 megawatts. And so what the presenter was suggesting is to profile your workload and maybe you only have to install 2/3 of the power that the peak power of the system can draw, because you're never exercising all the GPUs, all the CPUs, and all the memory at the same time. So that's an interesting one-off solution there. But I think to address this whole thing, it's going to take a whole host of solutions and at the same time an acceptance that the world's power, a larger portion of it's going to be going into these large data centers.
If I could also add a little bit too, I think it was a comment that I heard at SC24 was that everyone's either doing AI or cooling AI. And the notion of the acceptance and recognition of liquid cooling is certified and being adopted aggressively especially with the new data center build out. But when you're looking at existing data centers and folks that are maybe trying to retrofit liquid cooling to existing data centers, they're hitting speed bumps and challenges in that the power within their data centers was initially developed and designed that's still kind of only supporting the 10 to 14 kilowatt per rack. And, they're just not designed to support the 150, 160 kilowatt per rack or even upwards of the 400 kilowatt or greater per rack that's on the horizon. There could be some muting of adoption of the liquid cooling and addressing of the high power demand, especially when considering leveraging the existing data centers.
The one thing I'd like to add to that is I think there is a place for a power revolution in AI. The idea that maybe you don't need a 1.2 kilowatt chip to do training or to do inferencing, and that if you strip the computational requirements down to their barest elements, you may be able to offer an AI-centric accelerator that does far less outside the realm of what you need to do for those particular mathematical calculations. And if you can offer that at a lower power level and perhaps at a lower price than some of the general purpose GPUs that we see on the market today, there may be some opportunity, there may be some place for an organization to say, we can go backwards here. We don't need to extend this. And I liken it back to when we always judged microprocessor speeds by frequency, and then we got at some level and everyone said, this is crazy. Let's just change the paradigm. And I'm wondering if there is going to be some place for lower powered AI-centric hardware out there that adds a bit of diversity, if you will, to the ultimate selection process. And unfortunately, we don't have my colleague Tom on here where he would pipe in, because he lives in Ashburn, Virginia, where 80% of the internet goes through their 113 different data centers. There has been a data center under construction in Ashburn for the last decade and a half. There's a not in my backyard mentality growing. It's certainly in Ashburn, certainly in Loudoun County writ large, because there's talk about reopening 3 coal-fired power plants in West Virginia to supply energy to those data centers. And I think that there's going to be some significant consternation by a lot of different neighborhoods, organizations and such, who basically are saying, enough, we don't want to be the place that has nuclear power plants to supply people so they can ask where's the best place to have lunch. And I think that issue is going to, again, drive a reversal of fortune. I don't see 2 kilowatt chips. I don't see 3 kilowatt chips, just the same way I didn't see 6 gigahertz microprocessors at some point. So I think there's some nuance here that's going to be exciting to watch in the next few years.
Maybe that's a segue into an area that we're going to have to bring you back, Bob, to discuss, and that's quantum computing, which I know you track intimately. And as we were discussing at SC, of the benefits that it provides, one of them is energy efficiency. How do you see that whole area coming? You alluded to that there's a lot of progress, but also some disappointment with the level of progress so far. How do you see that environment?
The quick takeaway is, I think, and I'm pretty confident about the idea that within the next 3 years or so, we're going to start to see what the sector's calling utility class quantum systems, which basically means for a particular science and engineering job, most likely either optimization or computational chemistry, it's going to be more effective to do that on a quantum system than it is on a classical counterpart. And so I think we've seen enough roadmaps that have been in existence for a number of years, that certain milestones have been hit at a regular cadence, predictable one, that says that is going to be doable within the next 3 years or so. And so there's a lot of opportunity here. And you mentioned the power requirements. And whenever I tour a quantum computing facility, usually a manufacturing site, the first thing I do is run around the back of a machine and I look how thick the electrical cables going in are. And quantum systems are still running at the kilowatt range. This is 3 or 4 orders of magnitude less than a computational traditional classical counterpart. And that scaling is absolutely wonderful. It's not as if you double the qubit count, you double the power requirements. I actually saw a chip design a couple days ago. There'll be an interesting announcement in the next few days. Unfortunately, I'm under some NDA stuff. But the bottom line is I saw a chip package that holds a very small number of qubits, but it's the same qubit package that will scale to 10 to the 6th kind of qubit capability, all within the same package going forward.
Wow.
So the power requirement, and I've talked to folks about doing the math. If you're running a kilowatt range versus a tens of megawatt power range, if you can offload some percentage of your workload to a quantum system, even 5 or 10%, just from an energy perspective, that machine pays for itself in a matter of months, even if it had an original $20 million price tag. So quantum is coming. There's a lot of interesting progress going forward. And I think one of the untapped benefits of quantum is the fact that it gets you out of this pernicious cycle of more and more power to deliver more and more compute.
Yeah,
it's
definitely.
Almost a reset from a computational perspective.
Yeah. I don't know if the industry itself is really pushing on that yet. Maybe because they're not tracking GPUs.
There's a few companies that get it, and I'm not going to say I've been haranguing them all, but I'm starting to see roadmaps that actually list not only qubit counts and some of the other particulars that are unique to the quantum computing space, but also the idea of this is what our power consumption budgets are going to be in the next 3 or 4 years. So some organizations are really starting to wake up to that fact.
Excellent. Now, we talked about liquid. Do you see that happening across the board, becoming, and maybe the real question is really immersion. Is that going to happen? Because I think liquid is a pretty standard thing now. liquid plus air, that is.
Yeah, I think that, they're both being adopted. Liquid cooling and more so than immersion cooling. We did have a recent conversation where there was originally thought of a higher transition rate or adoption rate to get immersion cooling. That folks, even the vendors and the people tracking that market, have muted their expectation of that. And there's a number of reasons for it, but there's some. It is just kind of new, and it's been around for a while. But in the mainstream adoption, enterprise type of space, and even some of the HPC space, it's still relatively new. But there's some notion and a hindrance of some of the highest performing parts are warranted differently, or if at all, for use in certain immersion fluids. So there's usage consideration there that may mute adoption of immersion cooling. But there are elements, and we do see an uptick in adoption, but it might not be as aggressive as may have been initially thought.
I heard there were considerations with decay and that sort of a thing with various fluids.
There was one thing. I toured an all immersion cooling data center last year, and what was remarkable was the deafening silence in the data center because there were no fans.
That's right.
You walked in and it was eerie, just in what you're used to experiencing walking into an air-cooled data center.
And probably a lot of headroom.
Absolutely, yeah.
I had that same feeling, Mark, when I stood around the Frontier Exascale system. Think, where's the noise? It's amazing.
So one that I'd like to add to that too is we are studying lots of different types of liquids too for immersion cooling. So the different issues, Shaheen, you mentioned some of the deterioration issues in that too, can vary whether it's oil-based, fluor-inert-based, and single-phase, multiple-phase changed cooling in that. So there are a lot of different options still out there that people are exploring.
Yeah, exactly. I mean, they're all synthetic at this point, and I imagine you could formulate just the right mix so you can have the cake and eat it too. So I'm expecting that to be done any day now, right?
We keep watching it. We're watching to see what happens.
I know part of our discussion would focus on some of your more interesting, or what you think are interesting predictions for either the rest of the year or the decade or both.
Sure. I'd like to ask Bob to talk about quantum computing. There's been so much, shall I say, interest in the press and quotes by famous people about it could be 30 years away and things like that. And Bob, maybe you can address what our view is on that.
Yeah, sure. First of all, anything past 5-year predictions to me is science fiction. So I don't know how you can say 30 versus 29. And I do like the fact that right after Jensen came out with his pontification, Bill Gates came out with his. So famous people who are peripherally connected to the quantum space, who have more mind share than others, are to be taken with a grain of salt. I like to look at what the experts are saying, not the marketing department, but the actual folks that are involved. As I said earlier, the roadmaps are pretty reliable in terms of progress in quantum. The big thing here is application, or more accurately, algorithm development. There's still a limited span of use cases for quantum. And to me, the big, not surprise, but a development that I'd hoped for but didn't expect to see this soon is a growing enthusiasm towards on-prem procurements of quantum, moving away from cloud access models and bringing quantum computing into your existing, generally large, classical HPC ecosystem and starting to think about how I can integrate that quantum system into my workloads. And that's where I think we're going to start to see some amazing innovations going forward. The idea where I now have an application that's difficult to deal with, but I let the quantum system do what quantum does best, and I let the classic side of the house do what it does best, and I have these wonderfully interesting, innovative, hybrid applications. For the longest time, the quantum application algorithm realm has been dominated primarily by quantum people. And I think that unleashing the vast hordes of really smart classical programmers, mathematicians, organizations that develop algorithms and applications is going to offer up kind of a new frontier of hybrid applications. And I think that's really what's going to drive or propel forward quantum adoption, quantum acceptance, and ultimately the effectiveness and usefulness of quantum across the entire, and I'm not saying it's going to be used for everything. No, you're never going to check your email on your quantum processor. But I think that once it starts to get into the hands of end users who say, I need to do this, and what can the quantum system down the hall help me do? We're going to see a new birth, if you will, of insight and innovation. And that is, I think, part of what's going to drive the on-prem emphasis, bringing the system in-house and tying it directly to your existing computational workload and letting your programmers and your scientists and your software developers have 24/7 access to that system to rest out the computational performance capabilities. That's a little harder to get with indirect access through the cloud access model, which is what dominates today. So pretty positive about what's going forward. But I guess the surprise there was the growing interest in on-prem capabilities versus just maintaining cloud access, which is predominantly a great model for pay-as-you-go exploration, low barriers to entry for exploration, ease of switching vendors to kick around, try out different modalities and such, to committing to a particular modality, a particular vendor to optimize for your particular workloads.
Brilliant. Right on.
Doug, I would like to add another prediction that we have that we're expecting to see is some tremendous growth in budgets for the different machines, supercomputers, and Exascale and so on around the world. From our recent surveys, on average, people are expecting to increase their budget quite a bit, but there's really been a shift. We're talking now about $500 million systems as being quote unquote common, at least there's 3 or 4 of them. But at the more mainstream level, folks are planning to go from a 500,000-ish spend rate to something closer to 750,000, which when you go across the market is just tremendous growth there. But then the amazing part is there are a number of people talking about $100 billion expenditures, Microsoft, OpenAI, and the U.S. government. So these numbers are just staggering as far as the growth rate compared to just 3 years ago for a large system. And we think that's going to continue as a trend.
I'll also add another area that we're looking at, and Bob hinted, maybe even more than hinted at it when he indicated that trying to find the right application of AI in science and engineering, where 85% accuracy doesn't cut it. With the most recent hallucination there, where AI suggested that water only freezes at 32 degrees and it won't freeze at 27 degrees. But it also reminds me of I go back to war games and the Whopper the computer and the human from missile silos.
That's right. And you couldn't unplug it either.
But we're thinking that humanity will come back in inserting human oversight and into the AI process to really better tune and optimize and manage and minimize. You can make it more trustworthy. That as we bring the human element back into this process and not the full blind trust into what AI is doing, especially in the critical areas of some of this traditional HPC design. We want more than 85% accuracy with the design and development of a new airplane wing.
Right on.
Could I ask Mark, I have a sort of a pet interest in Interconnects Optical I/O. Talked with other folks who think this could be the year for Optical I/O becoming more commercially viable. What's your sense on that?
There's certainly a lot of interest and investment going on in optics. I don't think we're hitting a mainstream adoption for that yet. There's certainly some interesting things being done down at the both on-chip optics and on-board optics areas, some standardization with the interconnect elements down within the chiplet interface kind of areas. But there's still, I think, some challenges, especially in manufacturing some of the elements, with whether it's in the lasers and the connect and all that manufacturing the various optical elements at scale to be able to support broad mainstream adoption. So while the technology is there and some proof of concepts are really promising, broader widespread production and manufacturing, I think, is going to mute some of the growth and adoption of that.
Okay. Shaheen and I could go on all day with you guys.
We certainly could. It's such a treat. Thank you.
Oh, thank you so much.
Thank you.
Thank you. It's always good catching up with you guys.
Any comments or thoughts that we haven't covered that you'd like to do?
I just want to thank you for the opportunity to have the conversation.
Thank you very much. We look forward to staying in touch. A lot of activities, as you mentioned, GTC around the corner, quantum days left and right. Storage continues to be the complicated thing that it has been. So it's a delight to be able to catch up, and I look forward to us doing that again soon.
Thanks so much, guys.
All right,
guys. Thank you.
Bye-bye.
Take care.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.